Hello again, it's Damon, also known as Crazy Logics and Crazy Logics 007 on YouTube. That'd be Logics, Crazy Logics. Anyway, last video we were working on this amp, and I said something about fixing other things like a PlayStation controller and stuff like that. And we just finished doing some tests and putting that new chip on and thinking that drive was looking good. But if you noticed right at the end of that video, the driveway was starting to look a little squirrelier and squirrelier the more it sat there. And my son had came out and he was really wanting that PlayStation. Both of our PlayStation 3 controllers were broke and are not working correctly. And so I thought, oh, okay, you know, I'll stop and I'll fix one of his controllers. Maybe I'll do a video on that. And but before I did, I went ahead and I probed this a little more and I powered it up a little more because I was wanting to put them FETs in and stuff and everything else. And that signal kept getting uglier and uglier. And I was like, okay, hang on. So, you know, resistors are pretty easy to go with. You know, they either check good or check bad. They don't have nothing. But diodes are a semiconductor and they can leak. And with just a plain multimeter, and even with my little tester, you can't test them really for reverse leakage very well. They do make stuff to meters and stuff that will test it correctly. They use high enough voltage and stuff and stuff like that. But you know, the diodes that were in it were just these. They are little bitty 1N4148 diodes. These are one of the most common fast switching diodes there is. It replaced, and it's exactly the same as the old 1N914 diode. If you're going to get into electronics, you know, and you find a 1N914 diode, the new replacement for it is a 1N4148. And if you're going to get into electronics at all, order you up 20, 50 of these things whenever you make you a little electronics order. These little switching diodes are used everywhere. So, you know, we knew we'd had some damage that drives those FETs through the diode, and it's clamped back down by a little bitty resistor here. There's 4 of them total. And we didn't have the transistors in or nothing, and it was starting, that wave just kept getting uglier and uglier, and I said, screw it. So instead of doing the PlayStation video, I pulled the PlayStation controller apart real fast, found out it was because my son spilled some junk down in the controller, so I cleaned on it and thought, Dad, that ain't a good video. I'm not going to do that one. Anybody can take something apart and clean it. So we just cleaned it. There's 100 videos out there on how to take them apart and put them back together. So anyway, I got back to this and I was just really not happy with it. And so I said, you know what, I'm going to pull those diodes. They're cheap, and just see if I got leakage. And pulled them all out real quick, clipped my probe on, and the square wave looked fantastic. And I thought, man, those diodes might be leaking. Let's put 4 brand new ones. And so I just grabbed 4 new ones out of my little tray here. They're like this on a little thing. They're just tiny, and I went ahead and pulled the others out and stuck the new ones in. And so let's take a look at the scope when we run it now. Wait for that little light to come on. Look at how beautiful that square wave is. That is just beautiful. 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 Let's go ahead and go to the focus so you can really see that. Oh, it's not very well focused in. I've got my drink and my water there. Let's see, can we see it now a little better? Not too bad. So now it's beautiful. So I definitely said to myself, okay, those were leaking. I wish I'd changed them for you on the thing, but it's just, you know, using your desoldering tool, suck all the stuff out on both sides and kind of give it a wiggle, and they came out. And so there's 4 of them. They're going in the trash. And since we had the damage and leakage from there, I don't know that I trust these little pull down transistors now. You know, this thing's giving me enough of a fit that I'm just going to trash them, and I'm going to replace them with big known good ones. This is a BD 140. If you get the BD 139 and BD 140, that's the NPN and PNP. So the PNP one's the 140. There, all that stuff's in the trash. Transistors that normally you can use to replace all those others. Now you'll notice these got a different package. They got their labeling on the front. They're bigger. They actually handle more current. They're more rugged, especially if you get one that's where these little transistors kind of get hot from driving so many FETs in a big amplifier. It can make a difference, but you see on the board, maybe down here, where it's shaped flat with a curve, and the flat area is the front where the writing is, and the old transistor, I looked it up and made sure it was an ECB with the base going emitter, base, collector, because that's what these are. With the writing on the front, it's emitter, base, collector. No, sorry, emitter, collector, base. The other one's the other way. And that's what you're looking for, is you got to make sure you don't have a swap there that you need to, well, to be with the 2 3s. One of them will be different. My fingers are all goofy looking up at the screen here. But you need to make sure that those match, that so that you can slide them straight in as a replacement. Because if they don't, you're going to have to bend your legs around, and you'll actually end up with these. If it was to normally go in like this, but they need to be swapped, it'll end up being in like this, because you'll bend one leg forward, one leg back, and one leg over a little to get those in the correct alignment. And once you do, then bammo, you're good. So I'm going to go ahead and fit these suckers in here. Make sure I got my writing on the right side. And these are going to be the pull downs. They'll actually handle more oomph. Oop. I just whacked you guys. Are you okay? Are you dizzy yet? Whew. Didn't mean to whack you. Don't call, don't report me for abuse. So we got these all here. I got to get my glasses. When I get older, you got to have them cheaters. Let's go ahead and solder these suckers in. Hold your breath with me, so we don't suck any of this in. Well, the other thing I like about these bigger transistors for driving, man, they solder real nice. Big old thick leg. And they solder up real good. Sorry, force of habit. I hold my breath a lot when I do that, and that way I just don't breathe in any fumes if I can get my fume extractor running. So you'll always want to get you a pair of nips. I actually have two. This was a cheapo pair I picked up at Walmart in the jewelry making little area in the hobby and crafts, and I have already made the tips of them not very good. So they're good cutters back here, but the tip is not really good, and I was not happy that they wore out that fast. This one is the cheapo set from Tool Shop. These were at Home Depot. I normally don't shop Home Depot, but they have a lifetime warranty on them. So we will find out, but these definitely have a good cutter at the tip. Cut these legs off. While I'm doing that, I do have a computer power supply that I'm going to make a video on how to make a little benchtop supply for repair of things like amplifiers and other stuff. It'll be how to do it as cheap as possible. And then I am going to do a video kind of going over my bench. So always want to, we're charging a capacitor there. Make sure we ain't got any shorts. Oh, sometimes I can't see my meter. Yep, that all looks good. Alright, since we did a little soldering, I'm going to put a small squirt of alcohol to clean up the flux. And we'll get the hot air station to dry that up. See how there, I don't know if you can see that there's some of the alcohol went over to there, and just get that all to evaporate. Before we apply any power, I always like to keep it clean. I like to clean my flux up. Like I said, normally use rubbing alcohol. Last and final clean normally is done with acetone. Alright, so those in there, we should, well, bring up some power. Hope we don't get no sparks. This is live. This is right in front of everybody. We're going to go all the way to the gate here. We'll power up. Oh, and you guys can't see it because I'm a moron and didn't switch the camera view. You need to let me know if you like just seeing it up in the corner here so you can see where I'm measuring. I always like to be able to see where somebody was measuring. Here we go, we're going to turn it on. Oh, might help if I get good connection. We're on. There we go. Oh, I'm getting it on my scope, but not getting it on the camera there. Something's not right. Uh-oh, my scope didn't died on us here. Not my scope itself, but the camera for the scope. Give it a unplug and a plug in. It's locked up. Dadgummit. Boopy doo. I'm not sure. Hang on to your butt. We're going to see if I can pan you over. There's the scope. And what's let's grab the probe. And here comes the signal. There we go. That's what we're looking for. Nice and square. Okay. So, ooh, got a fat belly picture. I will try to fix the scope camera there. I don't know why it's locked up, but it is. And we will, turn the power off here. Now we can go back to replacing FETs. While I've got this on here so that I can just show it, we have a FET that needs to be replaced with a busted, oh, I'm getting all kinds of distortion there in my view. I may need to restart my computer. With a busted trace. So I would install this FET. Let's see if we can do it before my system dies on us here. Hopefully that something's definitely going squirrely. And the screen is rotating and everything. I'm going to stop this right here. We'll oh no, the amp was rotating. Okay, let's see if we can get this in real quick. So get a little solder. Ooh, a little hot. Get that sucker installed right there. Okay. So now, what I do is I take some of my solder wick, some narrow solder wick, and I look and see about how much I'm going to need. Not too awful much. Clip me off a little bit of it. I take a little O-ring pick. I poke a hole right in the middle of it, so that I can set it over that leg. Sometimes you got to work that hole back and forth a little bit because this is a braid. Alright, I'll get a hold of it. We're going to set that sucker right over there. Now it would be really easy to get solder bridges and shorts all in there. So what we're going to do is just add a little solder to hold it here at the very back end. Just a tiny bit. So we got a little bit right there. Take our tweezers and we're going to crimp this all up real nice around that leg where it's nice and narrow. So now it's on the board there, it's around the leg, and then we're going to solder the leg here. See how that's nice and done? And then when we go back to solder this, we're going to push down. Make sure it's flat in there against where that trace was. That'll soften up. I think we're okay on the recording. It doesn't seem to be freaking out right now. I sure hope so. I wonder if the scope... Nope. Dang it. So now I get my little continuity meter. And that's okay to have a little beep because it's charging up the cap. Alright, so that is how I fix traces on the power legs for any of the big stuff here. And wow, there's a delay in the camera. Okay, yep, we're going to have to stop this and see if it'll even publish. But I'm going to go ahead and put the rest of them in there, and the next time you see it, we'll be doing those caps. And I'm going to restart my computer. Like I said, we'll call this repair video like 3.5 or 4.5 or whatever, just in addition to. We got that fixed. We put in the new transistors. Give me a subscribe if you can, if you learned something or if this helped you out. Likes and big thing right now, comments. I got one guy that's commented several times and kind of inspired me to do a couple of things here and there. So give me some feedback that way. That'd be really fun. So thanks a bunch, and I'll see you when we get the caps in. Bam.